Okay, our last lecture for this chapter is about periodic trends, and a trend is a pattern. So I'd like to start you out with a little bit of a review. We did learn metals in semester 1, and just some physical properties of metals. They have luster, which means to shine, malleable, which means you can change the shape without breaking it, and luster and malleability, just think of like jewelry. If you have different charms that are in shapes and you want your jewelry to be shiny, not dull. Ductile means you can draw it into a wire. Metals conduct heat. If you do any sort of cooking with metal pots and pans, you understand they heat up rather quickly. They conduct electricity, and they are found to the left of the staircase. And the staircase that we're talking about is the staircase on the periodic table. So if you look, it looks like this, okay? And the first element at the top is boron. So anything to the left of this is considered a metal. Okay, nonmetals don't really have physical properties like the metals. There are some exceptions like carbon. Diamonds, the diamond form of it, which is the hardest substance on Earth, it does conduct heat well. But really there's no set property that I can tell you about for every single nonmetal. But what you should know is that they are located on the right of the staircase. So carbon, oxygen, a lot of gases, things like that are found on the right-hand side. And then you have these things called metalloids, which are have properties in between metals and nonmetals. And most of them are on the staircase itself, beginning with silicon, which is right around here. Okay? So you don't need to memorize these because they are on your table, but I did want you to know which ones they were. So silicon, germanium, arsenic, which is a poison, antimony, the symbol is actually SB if you're looking for it on the table, tellurium, polonium, and astatine. Okay, now, metallic activity has a trend, okay? So, we did learn that metals tend to lose electrons when they bond. This was back in the naming chapter. And energy is needed to lose or remove this electron. This is called ionization energy. It's energy needed to remove an electron from an element. Now, nonmetals tend to gain electrons, and they will also gain energy when they gain those electrons. So, what I want to show you now is what this actually means in terms of the periodic table. So, this is a trend, okay? And you can draw it in my notes, but I also recommend that you draw this on the periodic table that I gave you. So, here's the deal. We have two different trends. So, from top to bottom on the periodic table, the ionization energy, I'm going to label it IE, decreases. So the farther down you go on the table, somebody like francium compared to somebody like sodium, francium will require less energy compared to sodium. Okay, so less energy to remove an electron. As you go across the periodic table, the ionization energy increases. So if you look at sodium versus somebody like chlorine, chlorine needs more energy compared to sodium. Alright, the next trend is atomic size. And think of this based on the configurations. The larger the configuration, the more electrons you're filling in, the larger the atom is. And you can see these two trends, but I think it's easier if I just talk about it as I draw the trends. So here we go, atomic size. As you go down the periodic table, atomic size tends to increase. And if you just think of what's at the bottom of the table, these are a lot of your nuclear chemicals, right? So these are pretty big elements, okay? And as you go across the table, the atomic size tends to decrease. And the reason for that is that the electrons tend to stay closer to each other. They pull more towards each other as you go across the table. I tend to think of it as like hugging or squeezing together, and that makes the atoms a little bit smaller as you go across. Okay? So somebody like francium is fairly large, but somebody like phosphorus or sulfur is on the smaller side. Okay, and the last one is called electronegativity. This will also be important in our bonding chapter, so make sure you fill that in. And then I'm going to show you the trend. So from top to bottom, electronegativity tends to decrease. You do not have to look these up. I do not have these memorized. And as you go across the table, the electronegativity tends to increase. And for this one, there's one particular element that I'd like you to keep in mind, and that is fluorine. Fluorine has the highest electronegativity of any element on the periodic table. And what electronegativity is, it's the ability to gain or lose an electrons when bonding. Okay? So if this is higher over here, they have a high ability to gain or lose electrons compared to the larger elements towards the bottom of the table.